Hello Bearcats. Today we're going to review the properties of quadratic functions, both in general form and in standard form, or often we refer that as graphing form. Here are our two forms. Here's our general form right here, and here is our graphing form or our standard form right here. In the first form, it is symmetric to a line called the axis of symmetry, and you find that line by x equals negative b over 2a. Then you can plug that x, that gives you your x of symmetry. You may plug that value that you found for x back into the equation to find the y value, and that y value along with the x value will give you the vertex of that parabola. In contrast, in this form, which is a great form, your value of h and k is the vertex, and the axis of symmetry is x equals h. So this is a little quicker when you're looking for vertex or axis of symmetry. If a is greater than 0, it turns upward, and you would have a low part of your graph would be the minimum value, and if a is less than 0, the graph turns downward, and of course the top of your graph would be the maximum. That is the same for the other form. Also the same for the other form is as the absolute value of a gets larger, the graph narrows, and as the absolute value of a gets smaller, the graph widens. With both forms, you're required to solve to find x-intercepts, and we just went over some of those solution methods, which were completing the square, factoring, quadratic formula, or square root property. So all of those are ways to find x-intercepts. One more thing is that standard form allows you to graph by transformation. This form allows you to graph by transformation. So that makes it really easy if you're graphing. However, the y-intercept is easily identified in the general form. Let's talk a little bit more. Going from general form, so from your ax squared plus bx plus c to your standard form, which is a times x minus h squared plus k. So going from this form to this form, you're required to complete the square. So it's going to be very important that you can do that, because both forms give you lots of information at your fingertips to be able to help you graph and identify different things. I also think that in the standard form it's actually a little easier maybe to solve unless you can factor it, and then of course factoring is always your easiest. All right, let's do an example, and that will be all today. Tomorrow in class I am going to extend a little bit and talk about parabola as a conic section, and we're going to discuss the foci, the directrix, the endpoints, and the latus rectum. All right, I will one more example and then we'll be done. All right, we spent a lot of time in the last unit on writing equations of lines. This time we're going to write the equation of a parabola with similar information. With the equation of a line, you had to have a point and a slope. For the equation of a parabola, you need the vertex and a point on the graph. So here we've been given, this is the standard form that we're going to try to go to. We've been given our vertex and we've been given a point on the graph. The vertex you're going to label h and k, and the point, of course, would be x and y. And what we're looking for is that missing a value. So let's plug in what we know and solve for a, and then go back and write our equation. All right. All right, here we go. So the first thing we're going to do is we're going to plug in our y, which is 3. We don't know the value of a. Our x, which is 2, minus our h, so minus 4 squared, plus k, which happens to be a -1, so it'll be written as minus 1. All right, the next thing we're going to do is we're going to begin to solve. So we have 3, and here 2 minus 4 is a -2, but -2 squared would be a positive 4, so 4a minus 1. We're going to go ahead and add the 1 to both sides. So we have 4 equals 4a, and of course if we divide away our 4, a is equal to 1 in this case. That is not always true. Now we're going to go ahead and plug back into our equation. We're going to put in the h the k and the a, but we'll leave our x and y for different points on our graph. So our equation would be y. So go ahead and we're going to go y equals a, which we now know is 1, times x minus our h, which we know is 4 squared, plus our k, which is negative 1, so minus 1. And then we could actually go back and write it as f of x equals 1 x minus 4 squared minus 1. And that would be our equation. All right, go Bearcats. Get ready for our extension about refreshing our memory about conics and some warm-ups tomorrow. Go Bearcats.